Um, Good afternoon, everyone. Welcome to the Computer Society of India and Capgemini's webinar on platform engineering and the next evolution of DevSecOps for enhanced developer experience. We are thrilled to have you join us today for a crucial discussion on evolving landscape of software development. In today's fast-paced digital world, delivering secure and efficient software is more critical than ever. In our rapidly evolving digital landscape, secure and efficient software is paramount. While DevSecOps has been a crucial step, platform engineering takes it further. We'll delve into how it builds upon DevSecOps to revolutionize development workflows. Specifically, we'll explore how platform engineering improves developer experience, strengthens security, and simplifies complex processes. We'll cover the evolution from DevSecOps, the tools and the technologies involved, common challenges, and real world applications. To guide us through this intricate topic, we are honored to have Gurpreet Sachdeva with us. Gurpreet is a senior director at Capgemini, bringing a wealth of knowledge and practical experience to the table. With 27 years in the industry, he's tackled some of the most challenging technologies in communication software, DevSecOps, cloud computing, and cybersecurity. Gurpreet's impressive academic background, including a BTech from NIT Kurukshetra, an MS from BITS Pilani, and a certification from IISc Bangalore. He has led DevOps and DevSecOps transformations for numerous clients globally, and his insights are highly sought after. He's also a published author and a frequent speaker at prestigious conferences like DevOps India, CDCon, and DevOps Pro Europe. Gurpreet sir, over to you, please.
Yeah, thank you, Deepika, for kind words and introduction. Good afternoon, good morning, everybody. Uh, Thank you for joining today's session on platform engineering and the next evolution of DevSecOps. Let me just start sharing my screen and then we can go from there. Give me a moment, please. I hope my screen is visible.
Yes, sir.
Okay, so I think uh, most of us, probably all of you, maybe have already worked in DevOps and DevSecOps technologies, and we have seen the kind of benefits DevOps and DevSecOps bring to us. But in the last few years, what we have seen as a community in industry is that uh, the level of scale up that is required, that the kind of ask that is from our engineers, that is actually becoming, I would say, increasing the cognitive load, and people are not actually able to work in the best optimized manner possible. And then we came out with the answer as platform engineering, a core set of uh, experts, a core set of engineering teams, a core set of platforms which can help alleviate some of those challenges and which can really help in scale up to the next level. So that will be the basically uh, discussion point today in my today's session. So just to set the context, although we know what DevOps is and there are many definitions of DevOps, out of that, the one which I like is that it's a business-driven approach to deliver solutions using agile methods, collaboration, and automation, and has been detailed out by many, many reports. And one such example I'm giving is Accelerate State of DevOps report, that use of DevOps practices leads to high-performing teams, and which have consistently shown that in terms of throughput, stability, in terms of code deployments and lead time, etc., and recovery time from incidents and change failure rates, high performing teams which use DevOps practices have a better track record. Now, embedding security into DevOps, we get DevSecOps, which we can define as security enabled DevOps that emphasizes early integration of secure culture, tools, and practices into each phase of software development lifecycle, essentially making security checks and verifications, part and parcel of your regular agile CI/CD cycle. But we have been reaping these benefits for quite a few years. Uh, but off late, uh, in various industry circles, in DevOps community, people have started uh, realizing and noticing there could be certain challenges with the way we do DevOps and DevSecOps today. First of all, I think the thing is about having inconsistent implementations, especially true for larger organizations, larger groups. Like there could be different teams, and each team builds their own pipelines, CI/CD pipelines, and then infrastructure scripts, security policies, etc., which can lead to inconsistencies and duplication. Herein, a platform engineering team can help in standardizing infrastructure, CI/CD, observability, and security, and also creating reusable components for faster deployments. Then sometimes the development cycle and the deployment cycle can be a little slower. Developers often struggle with setting up environments, provisioning infrastructure, and debugging configurations, etc. Because essentially they're good at development, right? Because when we say developer, they're like the core expertise in development. And then here in the self-service platforms can help with automated infrastructure provisioning, speeding up deployments, and also eliminating bottlenecks. We have been trying to embed security into DevOps operation. And I'm also very passionate about having security being checked as part of your DevOps CI/CD cycle. But still, many a times I've seen it is considered as an afterthought, which can lead to vulnerabilities and compliance issues. So if you are doing security checks after a few sprints, like 2, 3, 4, 5 sprints, by the time the software is already into production environment, and if there's a vulnerability, your users are already exposed. Platform engineering embeds security compliances in a more disciplined manner because that gets embedded with the platform as such, and ensuring that the true DevSecOps principles are being followed. Um, DevOps teams are also facing challenges with increasing complexity, with microservices, multi-cloud environments, distributed architectures. And as organizations are growing, managing infrastructures and DevOps processes becomes chaotic. Herein, platform engineering can come and create a scalable foundation that supports multiple teams with shared infrastructure and best practices. So, common team will be able to share the best practices in a better manner. Um, and the cognitive load part, I'll be talking about that in more detail in subsequent slides. But just to set the context, DevOps requires developers to do basically multitasking. Like they need to handle operations, which is not always their core expertise. They're expected to obviously be experts in coding, but then being experts in infrastructure, security, operation, which becomes unrealistic as the complexity grows, as your system becomes more and more mature and scalable and grows in size, etc. Platform engineering abstracts complex infrastructure concerns, allowing developers to focus on coding, actually developing software, while still following best DevSecOps practices. Uh, Better automation, security, and governance, basically with minimal manual intervention. Now, I'm very happy that when we talk about platform engineering, the various industry experts and DevOps gurus and platform engineering gurus we actually started talking about the developers as such. When we talk about developer experience, it starts with developers. So someone is actually talking about how does a developer feel. Generally, we always talk about how would the client feel about the end product, etc. But actually, various industry experts are talking about how developers feel about the entire process and uh, working in that team or a group or an organization. So just to summarize, developer experience encompasses how developers feel about, think about, and value their work. And it can depend on many things like the kind of work you're doing, whether you're happy with that or not, the kind of hardware you're using, maybe even your laptop, for example, if it's not of good quality and it's not supporting you, you may not be in the best optimal state. And the kind of tools provided or not provided, for example, maybe there's a better IDE which can help you out, or maybe your company has helped you in getting a Copilot license. I mean, Capgemini for sure has invested a lot in those kind of tools also, which can actually help in alleviating some of your day-to-day tasks and which can make more happy engineers and adding to essentially a better developer experience. And three key areas or the three key dimensions of any developer experience we can say is that first is important is to have a proper feedback, the feedback loops. How quickly and well developers receive responses to their actions. Fast feedback loops allow developers to complete their work quickly with minimal friction. Then cognitive load is like how much of mental tasking or mental processing is required to complete a task. For example, cognitive load typically increases for a developer working on a difficult task or a complex task, or learning to understand an unfamiliar development framework, or maybe when you are coming new to a project and you want to learn about the existing system and technologies at that particular in that during that particular period, your cognitive load will be higher. And to improve developer experience, teams and organizations should aim to reduce cognitive load by finding ways to eliminate unnecessary hurdles in the development process. Then last, dimension is flow state. So I'm assuming most of you would have heard about when we talk about being in a state of flow. Basically, it's a state of energized focus and enjoyment while performing an activity. So if I truly enjoy working on a project or a product, then I'm in a flow state and which is quite focused. And then I don't worry about the number of hours which is passing out because I am actually working on those aspects. So I'll take questions in just a bit, and then we'll have a larger time for taking Q&A towards the end of the session. Um, and in order to improve developer experience, teams and organizations should focus on creating the optimal conditions for flow state. There's actually a lot of research being done on these aspects to bring about the factors which can affect developer experience. One such area and one such way of measuring developer experience is the SPACE framework, which has been evolved into this to analyze the developer productivity and the kind of cognitive load our engineers face. So the idea is to measure topics across the three dimensions. So we talked about flow state, feedback loop, and cognitive load. So measure different topics across these three dimensions. For example, an organization may choose to measure test efficiency or a code-based complexity, the tech debt which is remaining, and the time required for deep work. And some topics may map to more than one dimension also, and that's fine. And these three dimensions of developer experience provide a framework for identifying potential areas of measurement. Accurately measuring the full range of developer experience requires not only capturing developers' perceptions and workflows across these dimensions, but also overall KPIs. So KPIs help us in quantitative kind of measurement. Otherwise, just doing qualitative will not help beyond a certain level. And a comparative analysis of perceptual measures and workflows is necessary because neither one can tell the whole story. As an example, if you are making builds, maybe the you feel that the build process is quite fast, and it's basically you feel it's disruptive to developers if it regularly interrupts their work progress. And alternatively, even if developers feel content with the build process, using objective measures as build time, we reveal that feedback loops are slower than they could be and development workflows less streamlined than they might be. So hence, analyzing both perceptual and workflow measures is necessary to gain a complete understanding of the points of friction that developers encounter in their everyday work. And by focusing on individual factors only, you may risk losing track of the bigger picture and investing in the wrong areas. It is therefore important that we measure the KPIs for developer experience also, which can help in optimizing our overall experience. Now, I came across this message in this slide. Uh, Daniel Byron is another thought leader. He has very interesting talks and blogs, etc., on various topics related to microservices, cloud computing, DevOps, etc. And when I first saw this message, I felt very happy that when I started my career many years back, then the ask, which was from the engineers or developers, was very less in a sense that I was just supposed, I was a very happy coder, if you ask me, or a happy developer doing my thing, doing unit tests, etc. Then most of the system test is being done by others. And then there's another team which is doing acceptance test, etc., etc. Those were the good old waterfall days. And probably many of you may not even have worked with waterfall. Everybody is doing agile these days. But long story short, you see that the range of expectations we have from our engineers over the years in last, if I bracket it, within 5 year brackets. So we started with 2000 and we expect them to use IDs and deploy portal, etc. But then we quickly moved to Jenkins plugin, and then slowly to we went to Heroku kind of things, etc. And then now we expect in 2015 kind time frame, we had things like Docker Hub, we had the hyperscalers like AWS and their console, etc. And then of course we have Kubernetes, which has become the lingua franca of all cloud technologies. So we expect our engineers to learn about all of these and know about all of these technologies. And if that was not all, like since last 2 3 years, we have generative AI in picture. So right, so we all need to be experts, if not creating a LLM, but at least in knowing what is LLM and being good in prompt engineering and good in using some cloud AI ML services like OpenAI, etc. So the level of skills which we expect from engineers is increasing. And if you go to any social media site, maybe like let's say LinkedIn, and you see job descriptions for 5 year, 7 year, 10 year, experienced people, it's this heavy stack. So yeah, so the industry has such been, adding more and more complexity to our engineers. Um, so this pairs with the, expectation from developers to be responsible for, for all of these. And it has become a handicap for many organizations because, one person may not be able to, may not be an expert in all of these, areas, right? And the cognitive load, I would say this is probably one of the biggest factors which has increased the cognitive load in developers and setups, which become quite overwhelming and then leads to very inefficiencies in the system. Well, it was fashionable at one point of time when AWS executive Werner Vogels very famously said in 2006 that you build it, you run it. And that's how DevOps become, very popular and has become the de facto gold standard, which most of organizations have tried to build towards. And then this drove a massive shift left movement, with developers being responsible for more and more of their applications lifecycle and delivery workflows, etc. And as a result, some organizations were forced to find a better approach. They created platform engineering teams. The answer was platform engineering team to build internal developer platforms or combinations of technologies and tools combined to lower cognitive load on developers. Some examples, some early examples could be, let's say, like Netflix used their platform to solve developers' challenges to manage multiple services and software, knowing which tools exist and switching context between tools. Similarly, Nordstrom built a platform to become a North Star of self-service. Their platform helped remove bottlenecks in their provisioning processes and eliminate the need for people to log into production. Well, just a view that the range of tools which you see across various areas, whether that is CI, CD, security, logging, DNS, etc., Kubernetes and messaging and databases. And there's a diverse range of tools. And we do expect engineers to uh, be an expert at least in one particular tool, but then probably knowing about more than one, right? And it takes a lot of, I would say, passion to be successful and being, I would say, comfortable and expert in these many tool areas. So maybe I can pause for 2, 3 minutes. Maybe I can take a question or two if you have. So I won't be able to see the chat, but if you want to ask, you can ask a question. Okay, I assume probably there are no questions at this point of time. I'll move ahead. So now let's come to formally defining what platform engineering means, right? So we can have a formal definition like it is a discipline of building and operating self-service developer platforms for software development and delivery. You can think of a platform as a layer of tools, automations, and information maintained as products by a dedicated platform team and designed to support engineers by abstracting underlying um, complexities. For being successful in platform engineering, there are some fundamental elements which you should keep in mind. First and foremost, prioritize team structures and ways of working over tools. So what it means is that implement cross-functional teams with a mix of skills like development, operations, security, establish clear communication channels and regular sync-ups, and encourage a culture of continuous learning and knowledge sharing. Enable observability by implementing comprehensive logging, metrics, and tracing solutions. Establish clear service level indicators, service level objectives. Create dashboards for real-time visibility into system health and performance. Uh, it is better to have quantifiable measures for, to measuring the success of your platform. So define clear KPIs for the platform. Measure developer productivity matrices like deployment frequency, lead time, etc. And last but not the least, empower the developers to increase productivity. Provide self-service capabilities for common tasks like provisioning environments, deploying applications. Offer internal developer portals or service catalogs. And yeah, so these are the ways you can actually try to, these are the few fundamental items part of a big successful for platform engineering initiatives. So that and you can see this representation of a platform engineering team structure. This one comes from Gartner, and some organizations have tackled this by they create a separate uh, platform engineering product teams. So you treat your platform also as a separate product, and then there's a separate team responsible for handling those, I would say, products in this case. So platform as a product rather. So these teams, they operate an internal platform which enables delivery teams to self-service deploy and operate systems with reduced lead time and stack complexity. The emphasis here is on API-driven self-service and supporting tools which delivery teams uh, are still being responsible for supporting what they deploy onto the platform. Uh, and organizations that consider establishing such a platform would have to be very cautious not to accidentally create the same set of DevOps teams which were there existing earlier. And they should also not, just simply relabel their existing hosting and operations structure as a platform. So we have to be very cautious when we actually go for creating separate platform engineering teams, separate platforms, etc. You can think of like your companies, your groups, your teams, developers and engineers are customers for platform engineering team. Platform engineering teams also have to play another role. And I've seen with some customer interactions also is that sometimes your regular developers are little apprehensive about starting to use a new platform, etc. So the platform engineering team members will have to, in many cases, evangelize, advertise, and bring confidence to people that they should start using this new platform, which can help them in various capabilities. So now let's see what some of the analysts and strategic advisors are saying. So Gartner has identified platform engineering as one of the top 10 tech trends. So they say that by 2026, 80% of large software organizations will establish platform engineering teams. Then we have the Puppet State of DevOps report, which claims that 65% of organizations are saying that platform team is important and is receiving continued investment. And then we have the familiar Gartner hype cycle, which says that platform engineering will reach mainstream adoption in 2 to 5 years. So you can see that platform engineering is towards in the middle block towards the peak which is there. So yeah, so it's kind of approaching mainstream adoption. Almost all the thought leader and analyst are united in this viewpoint that platform engineering is becoming important and it's going to become mainstream adoption. So now let's see that when you start using uh, central platforms, when you start having separate platform engineering tools, uh, platform engineering teams, what kind of capabilities you can expect, what kind of benefits you can expect. Uh, First and foremost is like the operation of infrastructure. What it really means is infrastructure as code templates for provisioning and managing resources, self-service portals for requesting and managing infrastructure. Then you have monitoring of production applications, which basically means real-time dashboards for application performance and health, centralized logging, and log analysis tools. Security and compliance are built in. So through automated security scans uh, for code and dependencies, compliance checks, and reporting. Then it helps in project planning by integrating with project management tools like Jira, Trello, etc. Um, then compiling and making builds uh, that becomes faster through automated build processes with caching for faster builds and also artifact management and versioning of the build, etc. It helps in testing of your software in terms of making it more seamless for automating unit test, integration test, and overall end-to-end testing, um, test environment provisioning, management of your test plan, test environment, test case management. The whole thing becomes quite easier. Then you can easily automate your workflows, which will include your CI/CD pipeline orchestration, integration with external tools, and services via APIs. And of course, being a central team in a central platform, it helps you in deploying faster to production because there are less and less bottlenecks going forward. So, what do we do to become successful, to have a successful platform, right? So we have to do certain things in the right manner in order to make a successful platform engineering culture and team. And there are quite a few dimensions for that. So first and foremost, like there has to be a buy-in from all the key stakeholders. So engage with key stakeholders early and often and continuously. Clearly communicate the platform's value proposition, um, align platform goals with organizational objectives, provide regular updates and demonstrations of progress. Then it's important that we can actually look into team structures also. So establish cross-functional teams with diverse skill sets and implement clear roles and responsibilities. Or also try to foster a culture of learning, collaboration, knowledge sharing with regular team interactions and sync ups. So if you see this diagram, this is from another famous book, Team Topologies, which has advocated for various kind of team structures based on your organization and the kind of product you're trying to build. One of the common theme is having value stream aligned teams. So you can see that these are stream aligned teams, etc., for a complicated subsystem. And then there is a concept of an enabling team, which can, let's say, come out with some enablers, maybe some tools, maybe some frameworks, which are being used by all stream aligned teams. But then at the bottom, you see a platform team, which is separate. So it's a team structure in the sense that we have value stream teams, we have an enabling team, and then we have separate platform team. Now there could be one or more Scrum teams actually part of the platform team or any of the value streams. So that is, we have to decide what's the size of a particular team as such. But yeah, having a separate team with proper interaction with all the various engineers and teams. So feedback is another very important dimension. So implement continuous integration and deployment pipelines. Shift right of feedback is very important. Utilize feature flags for controlled rollouts. Collect and analyze user feedbacks systematically and conduct regular retrospectives and adjust based on your learnings. It is also important to actually make it easy for teams to use your platform. So I was talking about one client reference earlier, but maybe I can elaborate that. So that was very interesting, uh, the work which we did. So that client is one of the leading retailers in India, and their central team, platform team, had created you can say a central platform which could help with infrastructure, VMs, Kubernetes deployment, and all that kind of stuff. But for various reasons, the core engineering team, the application teams were not, enthusiastically using it. There were some technical challenges also. So we were brought in and we helped them in making it easier for the teams to adopt the central platform. But it was an important lesson for me also that just because if there's a new shiny tool and I may feel that it can solve all the problems, but maybe other people, other teams may not be willing to use it because they might feel that maybe there's an overhead of actually the initial migration process also. Yes, but nevertheless, what you can do is you can create comprehensive documentation and user guides, offer training sessions and workshops, showcase various success stories which are there and use cases, and also try to provide dedicated support for the platform users. So they get confidence in using the central platform. And have a product mindset, right? The platform is like a separate product. So treat it as a product with its own roadmap, prioritize features based on user needs and business values, implement a clear versioning strategy, regularly communicate platform updates and also improvements. And the last point or the last dimension for being successful in platform engineering is that think about continuously iterating because whatever we do today, I think very quickly that will become obsolete. Things are changing very rapidly. You may have to shuffle up tools, structure, processes, etc. So establish a backlog of improvements and new features. implement agile methodologies for incremental development, and regularly review and refine the platform based on feedback and metrics. Of course, stay updated with industry trends and emerging technologies. I can take a pause for a minute or so if there's any question. I hope all this is resonating with you. Maybe a yes, maybe a no.
Yes, yes, Gurpreet. It's really,
Yes,
it's an interesting.
Okay, thank you. I was thinking that probably I'm the only one speaking, no one is there on the bridge. So yeah,
No, no, no. It was
okay,
indeed.
okay. If there are
The
no further
concept
questions,
is the concept is a bit um, it's crystal, right? So we need to grasp it in a very thoroughly, actually.
that's
Because
true.
since we are coming from different walks of life, right? So platform engineering is such a complex. I mean, it's not a complicated one, but we need to understand it from the different dimensions as well.
I
Yeah,
agree. I
yeah,
think different people work in different kind of industry verticals and technologies,
yes,
etc. And
yeah,
I'm from coming from Capgemini ER&D, the Capgemini engineering team. So
yeah,
where we have many core engineering industries like aerospace, automotive, telecom, life sciences, etc., etc.
yes,
And they work in quite different manner as compared to your regular digital internet SaaS kind of verticals. And many people are still following V cycle. Think of it as like an iterative waterfall kind of a thing, which was a very, I would say, uh, niche thing to work in 80s, but still many people are following that. And then they work on
correct,
embedded software, and then they can't do a lot of, I mean, they need to do a lot of tests on the actual hardware. For an automobile, you need to test on the actual, car, for example.
correct,
And that becomes interesting. Then we have different layers and different dimensions. Uh, for those various industries, then you have to tailor made your DevOps or platform engineering uh, processes and tools and technologies, etc. Yeah, and I'll talk
correct.
about that also in a bit.
Yeah. And also the with respect to the tools, right? Everyone, since some of them will go for kind of tools like whichever the cloud industry is providing. Some of them will opt for the open source like Jenkins, and then this one. So it's depends on the engineering platform. I mean, depends on the vertical which you're coming with. It is from the client request, and maybe we have to adapt it that one.
I
So
agree.
yeah,
I agree. Many a times, client dictates that okay, I have already chosen these set of tools and let's use it. So I totally agree with you that most of the times uh, we have to use it in a way. But I would still suggest, and I've done that myself, is that I've seen people are open to suggestions. We can at least, if we know something which is good or better, we can at least suggest. People are open to hearing it. They may or may not, apply it because of various reasons, their
correct,
policies,
correct.
etc. But at least let's speak out and talk about it, so that will help.
Yeah, at least more later point of later point of time, at least they will think about that. Maybe that solution might work.
True,
Mm,
true,
yeah,
absolutely. Okay, I'll move ahead. So I think how platform and SRE complement DevOps. Now this is interesting. We started with DevOps, and then we had SRE. So we wrapped our head around, what is SRE and what is DevOps, how are they different, and etc. etc. So SRE became quite popular when we had the site reliability book from Google people, because Google started this practice initially, and then they wrote about it in their books, and it became popular. And of course, now Capgemini is also an expert and done a lot of stuff with SRE. And now we have platform engineering into the mix. So then, what do we pick? What are we like? And what are the difference? And what are the how they can complement each other? So that is Probably we could spend some time on this aspect. Uh, and I think it's fine if we identify ourselves as one of them, or we say that I think I can do all of a bit of everything, that will depend on engineer to engineer. But important to understand, how these three different areas differ and complement to each other. Well, some people might say that platform engineering is the next big thing after DevOps. But if you ask me that, in some sense, SRE and platform engineering are variations of DevOps only. So DevOps you can think of as an overarching philosophy, and then there are some specific, you can say, implementations like SRE and platform engineering. And platform engineering also is not something which is totally new. Uh, it's an emerging model which is focused on not only simplifying developers' lives, but also empowering them with a set of carefully curated gold standard tools. So, and then it's helpful to think of DevOps and platform engineering and site reliability in the context of this Venn diagram. So you can see that the common areas which are there, the overlapping areas. So whether you're a DevOps, a platform guy, or an SRE, you need to be proficient in coding for sure. Then you need to be stay up to date with new developments in organization, in your teams, and if you're working with a cloud hyperscaler, what is the latest and the best which is happening? You need to be aware, and what are other options available to you. Now, while DevOps engineers don't need to focus on system engineering, for example, if you're a DevOps, probably you don't need to be a Linux expert. You may or you may not. But platform engineers and SREs probably would need to know, let's say, about platform details also. And SREs need to manage offerings at scale across multiple cloud providers. I mean, that's the whole idea behind site reliability, right? That I have a site which scales to many, many hundreds and thousands of pods, and my service is always available and up, etc. So I'm offering uptime, I'm offering scalability, stability, etc. Uh, Similarly, platform engineers must understand systems in the context of the tools developers use. So while a platform engineer may not be directly responsible for scalability or stability, but it should understand the tools and the structures which are required to make that happen. Now, incident management or crisis management or downtime handling, that is key skill for platform engineers and SREs, which may not be required for a typical DevOps engineer. SREs need to do efficient fixes and debug issues during multiple failures of a business critical application. Another overlapping area is communication skills. So that is essential for all engineers. More true for SREs and platform engineers, as they have to interact with not only the internal teams, but to the external clients also who are raising maybe incidents and who have some challenges. So you need to communicate properly with them. I would say platform engineers also need product management skills, or maybe you have a dedicated product manager as such, who's responsible for maintaining or building an internal base for development teams, and must also understand changing requirements and use cases over time. So yeah, I think you can see that same but different. Like these different approaches have similarities, have overlaps, but then they have their own finer nuances also. So I think in this slide, I just wanted to give one perspective. I'm sure if you are already working on platform engineering, uh, so basically you would know that you may have done their own way of doing platform, etc. So something which we have done in CAP engineering, I just want to talk about that a little bit. We have our own continuous delivery platform by the name of Software Engine, and it encompasses a comprehensive suite of software processes, methods, and tools, making it a robust platform as a service. It's being used by multiple clients in different industries. And we have recently integrated with GenAI toolkits like GitLab Duo also, and so engineers can optimize their activities using GenAI. I guess now going forward, no discussion of platform can be complete without talking about generative AI. So why I say it's a complete platform is because of three layers which is supported, three core capabilities it has. First and foremost, uh, I'm sorry, the question or a comment?
No, actually, I'm busy right now. Thank you.
Okay, I'll request to be on mute,
Sorry,
please.
sorry, I have a question, but I was requested earlier, so may I ask?
Give me 2 minutes. I'm wrapping
Okay,
up
sure.
and then I'll take all the questions. Okay. So the first layer is about the software engineering processes, which we define. So how Capgemini engineering, ER&D delivers engineering, covering the activities from requirements definition to maintenance. It also includes transversal activities such as configuration management and estimation. Different life cycles are supported to address various project needs. The current life cycles we support are like Scrum, Kanban, vCycle, service catalog, safe, etc. The next core capability of the layer is like the actual DevSecOps platform, the actual delivery platform. And the focus is to enable the projects to start using productivity and engineering tools right from the very beginning. The tools have been customized as established by the software engineering process, which sets a common way of working across our organization. And this leverages the best practices across the organization and promotes reusing of the training materials. And it also enhances collaboration, enables knowledge sharing, and facilitates the efficient exchange of data and artifacts between teams. And the last capability is actually, which is very essential, is the actual platform engineering team. So uh, it's offered as a service. It's a fully managed platform as a service with a dedicated management team, service and training catalogs, shared services built on top of the platform, and tons of training material, ton of you can say onboarding material, etc. is there. And we have seen over the years it has brought in a lot of benefits to various projects in terms of improving productivity, making us a lean and agile organization to get more business, and also having security as a way of life. Yeah, I think towards the end, I can conclude by saying that platform engineering is a transformative approach that empowers developers, streamlines operations, and accelerates innovation. And by focusing on self-service capabilities, automation, and standardization, we create an environment where teams can work more efficiently and effectively. The benefits are clear: improved productivity, faster time to market, enhanced reliability, and optimized cost. And as we look towards the future, I believe that platform engineering will continue to evolve, integrating new technologies and methodologies. And the challenge lies in balancing standardization with flexibility and keeping pace with rapid technological changes. I would encourage you, all of you, to assess your current practices and consider how platform engineering can drive your team forward. And as always, remember to start small, iterate often, and always prioritize the user's needs. So with that, I would like to thank you all for being patient with me, and I would be happy to take any questions if there are.
Yeah, Gurpreet, thanks for the session. I have a question on the slide 11.
Mhm. Slide 11, is it?
Yeah,
Let
yeah.
me go there. Give me a
Where,
moment, please.
yeah, Venn diagram.
Just a moment, please. Let me share for everybody's benefit. Yeah, you had a question here, right?
Yes, yeah. Can you just zoom a bit?
Is it okay?
Yeah, say in the intersection of all the threes, it's mentioned like perform software development means sorry, but I didn't get means why it's development in the common section because generally the developer so or I am missing something here.
Yeah. So see, obviously, it becomes very apparent that a DevOps, when we say, so it's we expect our DevOps engineers to be regular engineers who are doing actual software development also, right? But in case of SRE and platform engineer also, we expect them to at least do development from perspective of, let's say, scripting, automation of their tools, and those kind of things. So they actually have to uh, know how to develop software, but that software may not, for example, you're making a system in, let's say, Java, for example. So the SRE or a platform guy may not be an expert in Java, or at least he's an expert in shell script, bash script, Python, etc. So he can at least do development from that perspective of his script, etc. Those kind of things.
Okay, but that is not the like a business logic, right? What I understand.
No, yeah, that won't be the
Okay,
business
okay,
logic,
okay.
certainly.
Yeah, thank you.
Yeah. Yeah. Any other questions?
I have had a question, but it was answered in the previous slide.
Okay. Any feedback, at least if not any questions, any suggestions, feedback from myself, I'll be happy to have it. If not now, maybe later also.
Actually, this session actually cleared a lot of my doubts. So I was having few queries around what an SRE as a engineer will do and what exactly the DevSecOps as a practice will be doing in any field. Thank you for the session, Gurpreet.
Yeah, and I think what is important is that these role definitions are not cast in stone. For example, based on the team, organization, your client, the roles and responsibilities or duties will change across these different roles. So yeah, that would happen. But my idea today was to give you the broad contours or the broad framework, and then as per your requirements and your client, aspirations, you can basically fine tune as per your requirements. That's the idea here. But yeah, I think as I had said in the beginning of the session, typically when we go about reading various industry trends and thought leaders, etc., they all talk about, of course, software tools, customer value, etc., etc. Uh, Actually, as part of platform engineering, I am very happy that we are industry leaders, they are DevOps gurus and platform gurus who are actually talking about developer experience. They're actually talking about making the lives of developers more comfortable. So that I'm very happy about. So at least people are beginning to notice that.
Yeah.
Any more questions, please? I guess they're all clear.
Yeah, I think everybody is now going to start platform team from tomorrow.
So with that, we'll end our session today. I'd like to thank you, Gurpreet sir, for sharing your insights and expertise on platform engineering. And Computer Society of India also extends its sincere gratitude to our audience for joining us today. We hope you found the session beneficial, and then you'll be able to apply these learnings in your own work, start something new. We're happy as long as it's helpful. So once again, thank you all, and we look forward for you to joining our other upcoming webinars soon. Thank you.
Thank you all.
Thank you. Thank
Bye.
you. Bye.
Thank you.
Bye.
Thank you.
Thank you.
Thank you.